Hey guys, want to build a robot? Man, I love soldering up a new circuit board. You know, the process is so much fun. You design your circuit board, you put so much care into it, you get that circuit board shipped over to you, get all of your components, and you're working so hard to solder it together, and you're never quite sure if it's going to work. But then you put all of that care into it, you turn it on, it comes to life. Man, that whole process can be so inspiring. And so, as a lot of you guys know, whenever we ship our robotics kits out, we offer them pre-soldered, right? We solder them here at ACBR headquarters and use an industrial hot plate to make sure those surface mount components are all on there nice and good. But we have a lot of people who pick up our kits not pre-soldered. And that gets so exciting, you know. We love getting to ship out those kits that are pre-soldered, but also we have so much fun getting to talk to people who go through that journey of trying to solder one of these kits by themselves. And so this video is meant as a guide for anyone who's trying to do that right now. So through-hole soldering is not very difficult, you know, but sometimes people can be intimidated by surface mount soldering. The ACBR Voyager and Explorer does have a few surface mount components on it. The smallest components are Oh5. And if you're soldering Oh5 for the first time, you might look at the component and say, okay, that's smaller than a grain of rice. That being said, it is totally possible to solder using minimal equipment. We're talking maybe a pair of tweezers and a soldering iron. So this video is not meant to be the most textbook professional way to do surface mount soldering because there are a million different ways you could do it. It's meant to show you guys how, with a minimal amount of equipment, you can have a really fun time soldering up one of our kits. Let's get started. All right, let's go ahead and get started. So this is actually a really fun board to build. This is one of my favorites to manufacture. And we're gonna start from most difficult to easiest. So we're gonna get some of the smaller components in the center of the board out of the way, and then we'll move on. The first thing we're gonna solder up are our 1UF capacitors. Now, these are Oh805 size, so they are pretty small. Now, I recommend soldering just one pad of the two pads for each capacitor. So here, I'm gonna solder just one pad. I wouldn't recommend soldering both because then it can be difficult to heat up both at the same time to get the component nice and flat. So your first step is just gonna be soldering one pad of each of those three capacitors. And all of those capacitors right there, C10, C9, and C13 are all the exact same size, that 1UF Oh805 capacitor. So here we see I've just got one pad soldered on there. I would also recommend getting a pair of tweezers. They don't have to be any kind of super fancy tweezers, but it can be really helpful. So we have one pad soldered here. So if you heat up that one pad, you can sort of slide that capacitor into place. And you really want to make sure that you get this nice and straight. So it may take you a second to get that placement right, but you just want to get that one half there perfect. And once you have that, you can go ahead and solder up the other half. And that's why I only recommend doing one at a time, because now the component is really nice and flat, and you can kind of mess with it and add a little solder or take some away if you need to. And you're going to go ahead and do that exact same process for all three of those capacitors. Again, that's C10, C9, and C13, all the 1UF Oh805 capacitors. Make sure you don't have any solder bridges. Make sure those components are nice and straight. And you're good to go. So next we're going to solder up one of the Oh805 resistors. Now this, we're going to use the exact same process. Is this resistor right here, R6. So R6 is going to be the 3.3K ohm resistor. We make sure to separate the two surface mount resistors because obviously they look really similar. But the process is going to be the exact same. So you heat up one side, slide that resistor into place, then remove heat but keep the tweezers on there for a little bit. And once you're satisfied with that, solder up the other side. Okay, next we're going to tackle the other Oh5 resistor. Now this is going to be R5, and that's going to be your 10K ohm Oh5 resistor. So here you see we have that same process, making sure it's nice and straight, getting both sides solder in, and you're done. The next most difficult part is going to be the DRV8871. It can be a little bit tricky. This is definitely the most important that you don't get a solder bridge, only because we have 16 plus volts going to that, and if you shorted that out, it'd be pretty dangerous. And so with the DRV8871, you'll notice that there's a line on the top of the chip, and this can be pretty tough to see, especially in this video. But that line has to line up with the small dot that you see on the footprint on the PCB. That's super important. If it's backwards, it's not going to work. And keep in mind that one half of the DRV8871s are facing one direction, and the other half of the circuit board, they're flipped. So it's really important that as you solder all four, that you make sure that the line on the DRV8871 is lined up with that dot. We're going to solder this component in the exact same way that we soldered in the others. So we have just one leg, just one pad soldered in. And make sure that you get this nice in the center. So you see I'm a little bit too far over here to one side. So just heat that pad up. And once you have it nice and straight and also right in the middle, you are good to go. And you'll solder up the rest of the legs of the DRV8871 just like you did the first. Next, we're going to be soldering up the capacitor for that motor driver circuit. So this is the 100 nanofarad surface mount capacitor. And you'll notice too that this capacitor is way larger than the 0805 capacitors you were soldering before. So if you have any question as to which one, look for the 100 nanofarad and the much larger surface mount capacitor. Now that being said, the process is going to be the exact same. Making sure it's nice and straight, both sides soldered in well, and you'll want to make sure you do this for all four of them, for all four motor drivers. Alright, next we're going to be soldering the surface mount resistor for the motor driver circuits. Just like the capacitor, the size is way bigger than the other resistors you were soldering before. Follow that same process of soldering in one side at a time, making sure the component is nice and straight. And once again, you'll do that for all four of that same surface mount resistor. Okay, so now we're going to move on to the surface mount capacitor for that motor driver circuit. Now this is the electrolytic capacitor, and it is much smaller than some of the other ones that you have in your kit. So this is really important. This is going to be your 47 UF surface mount capacitor, and this is a little bit trickier than the other capacitors you've done because there's some plastic involved and you want to be careful. But what's nice is it's really easy to tell the right orientation. You'll see there are little cutouts on the bottom square that will tell you what's what. And also there's a little black half of that capacitor. So you see here, I have the black half matching with that white half on the board itself. Also, the shape of the component lets you know which way is which. But other than that, the process will be the exact same. You'll solder up one pad, heat it up, slide that component into place, and then solder on the back part. Okay, so now we have one of our crazy high power components. So this is going to be the XL4015 buck converter. This is what drops that 16 plus volts down to a nice steady 5 volts for our servos and for our ESP32. And so this component, the legs are way bigger than, say, the DRV8871. So if you're able to solder those up, then this will be totally fine. One thing I'll tell you though is that we're going to solder the legs first. And if you notice, there's a large pad on the back, and we're actually going to solder that later when we switch over to a larger solder. So right now we're going to worry about just these legs right here, and you're going to solder them up just like you did everything else. So put one in place and then solder in the rest of them. Okay, so now we're going to be soldering up another one of the capacitors for that buck converter circuitry. This is going to be our 220 microfarad surface mount capacitor. They look very, very similar. This one, the yellow color, makes it stand out. And also it'll be labeled just like all your other components, but the process is going to be the exact same. So the plastic, the shape of that plastic piece tells you how it goes, and also the orientation. So be sure to solder up one pad, heat that pad up, slide the component into place, and you're good to go. Now, this particular capacitor doesn't have that marking on the top that helps, so you may want to go by the shape of the plastic piece, so that way you know that you're getting everything in the right place. Next, we're going to be working on our 330 microfarad capacitor. So this is going to look a little bit different than the last one you used. It actually looks really similar to the 47 microfarad capacitor used for the motor drivers, just a little bit bigger. That being said, it's going to go on the exact same way. Alright, next we have the diode. This is really, really important. Like some of the other components, this has polarity, and this can be kind of tricky to see. So the diode that we're using here, it does have a marking. So if you look here on the left, it's really hard to see in the video, but it should be easier for you to see in person. There's a line on the left of that diode, and if you get this backwards, the whole project is going to be is not going to work. So it's really important. So you'll see there's also a line on the actual footprint on the PCB, and it is crucial that those line up. Once you find the line on your diode and you find the line on the circuit board and you match those up, then it's super easy, and you'll solder the component just like you did. And this one is way larger than the some of the other components, so it's really not tricky. It's just that orientation that's really important to get right. Okay, so next we're going to solder up the inductor. The inductor is a really, really important part of this buck converter circuitry. So we have a really nice, high-quality surface mount inductor here. Now, unlike the diode, the inductor doesn't have any polarity, so there's not one right or wrong way to position it on there, which makes it pretty easy. So one thing I will say, though, is I've actually switched now to a wider soldering iron tip. You can totally pull this off with the same one you've been doing for the whole build. I'd recommend probably a thinner one for the beginning, but I personally like to switch over to a thicker soldering iron tip for the end, the last few components, because we have a lot larger components that take a lot of heat. and it can be easier to put enough heat to really get that stuff melted. So other than that, the inductor is pretty straightforward. Okay, so believe it or not, we actually have just about finished our surface mount components here. Now the rest of the board, with the exception of the battery holders, is all going to be through-hole, and the through-hole stuff is really, really easy compared to the tiny surface mount stuff we did in the very beginning. So if you're able to solder that first stuff, the rest of the build should be super straightforward. We have the battery holders. Now those are surface mount still, but we're going to do those at the end, and I'll explain why once we get to that. But the first component you're going to want to solder in is the power switch there. And I apologize, I don't have any footage right now of actually soldering that in, but it is really straightforward. That being said, if you're curious about how to solder in these through-hole parts, you're going to see in just a second how I go through and how I recommend soldering in these components that we have for this last half of the build. Okay, so next we're going to do the headers. Now this is how we create the socket for the ESP32, and there are definitely more than one way to do this. So I'm going to show you probably the worst way. I know that sounds kind of weird, but this is way easier if you have someone helping you. Also, if you have some tape lying around, like some electrical tape, I would definitely recommend taping the component down from the top, so that way you don't have to use this method that I am here. The reason I'm showing you this method is because if you're by yourself, you don't have anyone else's help, this is how I would recommend doing it, and that's kind of holding the solder with one hand and the component from the back, and then doing just one pin. Even if you do have someone helping you, I recommend only soldering in one pin, because then you can make sure that it's straight. And then once you have one side, I would do the first pin of the opposite side. So you just have two pins on the front and back first. That way you can make sure all of your components are really straight, because if those headers are crooked, then it's going to be a lot harder to plug in your ESP32, or you could damage it because it would break off. And so it's really important that you get that right. But once you have the both edges of the headers plugged in, then it's super easy, and you can just go down the line and solder the rest of the pins in. So here you see I'm using the larger solder tip, but I'm still using that nice small solder. And again, you could use pretty much any solder tip you want. But for these last components, I use the larger soldering gun tip. Okay, we have all the components in. We have no solder bridges. Looking pretty good. Okay, so now what we're going to do is we're going to solder in the headers for the servos as well as for our power pins. So we have two headers for 16 volts ground, and we have two headers for 5 volts and ground. We also have the 4 servo headers. And so if you look at the header pins, there's a long side and a short side, and it's really important that the long side is what is facing up. Now, just like with the other headers, if you have some tape, like electrical tape or even Kapton tape, I would tape these components down, then flip it over and solder it. But I'm using that same method because I'm soldering this up by myself here. But other than that, the process is the exact same. Again, you want to watch out for solder bridges. Also, I would go with just one pin at a time in the beginning, so that way you can make sure it's nice and straight. Also, too, as you're holding the header pins down, be sure to hold the back of the 3 headers if you're soldering in the top, because obviously if you're holding on to that pin, it'll get really hot. So make sure that you're not heating up the pin that you're using to hold the header down. Other than that, it's pretty easy. Okay, so I've been using some really nice thin solder so far, and you could absolutely keep using whatever solder you're using, but I'm actually going to switch to a thicker solder. And this solder is maybe a little overboard, but it's really helpful for the batteries. And so I'm also going to use the thick solder for the screw block terminals. So we have the screw block terminal, we have the battery terminals, and also for the XL4015. So we have that last pad that we haven't soldered up yet, and it's going to be really nice and useful if we use that thicker solder with the wider soldering iron tip. So here you can see I'm using that thicker solder, and this is just a really big pad, and so if you're using a smaller tip, sometimes it can be hard to get the heat in the component. It is absolutely possible, but this is just probably the easiest way to get it done. So now we have that back pad of the XL4015 soldered in and good to go. Next, we're going to do the screw block terminals for the motors. And these are really straightforward. Just make sure, of course, that you have the openings facing the outward. And that you don't have them on there crooked or floating. Make sure they're really nice and close to the board. Other than that, they are really simple components. Like we said, we're starting from most difficult to easiest. And so here we are. You don't have to be super accurate. Obviously, you don't want to have a solder bridge, but they're just not difficult components to get in. Okay, so we have reached the final component, the 18650 battery holders. So to get these on, you're going to want to make sure that you put some solder on all of the pads starting off. That's going to be really helpful. And also, the 18650 battery holders that we use are really good. They can handle a lot of power. They do have markings on the inside that say positive, negative. I would follow those. I would take a second to find that one. The process is going to be really similar to our other surface mount components, but it's just going to be really important that you keep heat on there for a really long time. So you're going to want to make sure that you press down, you put a lot of pressure on the top, that you make sure that you've melted all of the solder. It may take 20, 30 seconds or so. Now the pads are really, really wide, so there's a lot less risk of burning the soldering, burning the circuit board or burning the component. As long as you're only using the soldering iron on the copper. But other than that, the process is really easy. So I would make sure there's a good amount of solder on there and it's nice and strong. So once you have that, your circuit board is complete. So here we have the ESP32 plugged in, and we're going to go ahead and test out our board. Keep in mind the batteries, all the positive sides are there on the right. So be sure you don't plug one in backwards. Otherwise, you could burn out the board and ruin all that hard work that you just did. So I really like using 18650s because, you can swap whatever kind of 18650 you want. So say you want to use some flat top, genuine Samsung, LG cells, go for it. Here I'm using these more generic 18650s. They're still good batteries. They get the job done. But here what I'm doing is I'm testing the voltage. So it's really important that you make sure that all your batteries are fully charged, or at least very, very close and balanced. So here I'm not quite at 4.2 volts, which would be full charge, but all of my cells are within 0.01, 0.02 volts of each other, and that's really, really, really important. And balancing those cells is crucial, because if not, they'll try to balance themselves rapidly, and you could run into a problem. So I would just be patient, make sure you charge all of your batteries together, use the same manufacturing batteries, and just be patient. And once you have all of your batteries and they are the same voltage, then you're ready to install them. So again, we have all of the positive sides facing the same direction there. And we have the moment of truth. Sure enough, it turns on. We are good to go. Looks like this board is functioning the way that it should. Now, there's one more thing that I like to test whenever I'm done with the boards before I actually plug in the motors and program everything. And that's the voltages of the buck converter and the voltages going to the motor. So the first thing I'm going to do is check the 16 volt line. And I would actually recommend putting the positive lead of the multimeter on the 16 volt line, but use a different ground, only because they're really close together. So here I'm using the ground of one of the servos. And sure enough, we have a little over 16 volts. It's good to go. And I do that just so I don't short anything out. So here you see I'm using the 5 volt positive, and I'm using another ground of one of the servos. And sure enough, I have 5 volts on the dot. Again, that XL4015 is really good for dropping that voltage down. So congratulations, if you have made it to this step, you have a fully functioning board. Now, there is one more step that's going to be really important, and I'm not going to show it in this video, and that's cleaning the circuit board. So there are a bunch of different ways you can clean the circuit board, and it is really important. So we get lots of flux on the board, the flux inside of the solder that we use. Also, if you use extra flux, you can get pretty messy. And so what I usually use is a little bit of acetone and a Q-tip. And I rub that on there, and that'll clean up that flux really well. There's also flux removing pens you can get that are great too. But if you're using that stuff, just be super careful that you're well ventilated and that you're being safe. But other than that, your board is done. I hope you guys have a blast getting to program this and building the rest of the robot. We have videos about all that stuff on our website, also here on our YouTube channel. Thanks for watching, guys. Have a great day.